everyone, and welcome to the channel. Today, we're addressing a core concept in Power BI that's essential for effective data analysis: the distinction between calculated columns and measures. I'll simplify these concepts, clarify their applications, and highlight their key differences with practical examples. My aim is to provide you with a clear understanding to enhance your Power BI skills. If you're looking to master these fundamental elements, please subscribe and enable notifications to stay updated. Columns are like the labels printed on your photos. Each photo has fixed details like the date it was taken, July 10, 2023. The location, beach, mountain. Who's in the photo, John, Jane, family. These are permanent facts attached to that photo. They don't change unless you go back and edit them. In Power BI, columns are the raw, stored data. Fixed values, always available, do not change when filtering. Say it like this: this is what happened. These are my facts. Measures, the insights you ask for. Measures are what you want to know about your album. How many beach photos did I take last summer? What's the average number of people per photo? How many photos feature just John? The answers depend on what you're looking at. If you filter by date or location, your answers change. In Power BI, measures are dynamic calculations. Change based on filters. Answer questions provide summaries and insights. Say it like this: this is what I'm asking about my facts. The answers change based on what I'm filtering. Now that we know calculated columns versus measures, let's see them in action. We're working with a fictional sales dataset containing 100 rows. Each row represents a transaction and includes fields such as product, category, price, quantity, and date. Using this dataset, we can explore the difference between calculated columns and measures in Power BI with practical examples. This table lists the products along with their prices and quantities. We'll use it in our first example, where we'll calculate the total cost for each item sold by multiplying price by quantity. We don't need to summarize the data here because we're not looking for a total across all products. We just want to know the total cost for each individual item, row by row. For our measures, we will need to create a measure table. Name it Measure Table. Wait for it to load. To calculate the total cost for each item, we'll create a calculated column in the sales table by multiplying the price by the quantity. Now that we've calculated the total cost for each item, we'll add this new column to our table to see how much each product actually cost in total. That's one example of a calculated column. It's a new column we created that calculates something for each row, like total cost. Now let's move on to example 2. We need to find the total money earned by the shop. This time, we're not interested in row-by-row values. Instead, we want one number, the overall total of all sales across the entire table. To do this, we use a measure, because a measure performs a calculation based on the current filters or context in the report. The DAX formula we'll use is total sales equals SUMX sales price * sales quantity. This formula works by using the SUMX function, which goes through each row in the sales table. For every row, it multiplies the price by the quantity to calculate the total for that single sale. Then it adds all those results together to give us one number, the total revenue earned by the shop. Because this is a measure, the result will change automatically depending on what we filter or select in the report, such as showing total sales for just one product or 1 month. This makes measures perfect for summary insights and dashboards. We delete the column because we do not need it. Let's add the total sales we have created on the dashboard by inserting it from the new card visual. Let's format it to look organized and well-aligned. Leave the layout as it is because we will add new measures. For the values, let's set font to Seago semi-bold and size 45. Align to center. Reduce space between label and value to 0. Now resize the visual. Let's make some adjustments to the visual to look a little better. We want to categorize each sale based on its total cost. If the total cost is greater than 200, we'll label it as a big sale. Otherwise, label it as normal. Go to the sales table and add a new calculated column with the following DAX formula. This formula calculates a new value, either big sale or normal, for each row in the sales table. The new column, sale type, didn't exist before. We're creating it using logic. It becomes a permanent part of the table in the data model, just like any other column. It helps when you want to categorize, filter, group, or visualize data based on custom logic. We will add it to our table, then format it. Click the Format pane and then go down to Column Elements. Under Series, select Sale Type, then turn on Background Color. It will open automatically. Leave everything as it is, then set the rules. If value is big sale, then green color, else if value is normal, then yellow color, then click OK. It looks okay, and now we can understand which product has big sale or normal sale. Let's adjust our sales type. Instead of 500, let it be 200. We can see that most products has big sales. I think the background color looks shouting. Instead, let's change the cell element to font color. We will also adjust the values to Sego's semi-bold. Just like with background color, we set rules here as well. That is it, we have created the sale type column and formatted it. Let's go to the next question. We want to calculate the average value of a sale, based on the price and quantity of items sold. Average X goes row by row through the sales table. For each row, it multiplies price by quantity to get the total value of that sale. Then it calculates the average of those values across all the rows. Let's write the formula. Now that we've calculated the average sale using our measure, let's add it to a card visual to display it clearly. With the average sale measure now added and working as expected, we're ready to proceed to the next step. We want to extract the day name like Monday, Tuesday, etc. from the date column to better understand which days generate more sales. Use the following data analysis expressions formula to create a new column in the sales table. Our day name column is now created, so let's add it to a visual. Go to the Visualizations pane. Select the line and clustered column chart. Add day of week to x-axis. Total sales to column y-axis. and sales average to line y-axis. Let's now format the chart. With the day-wise sales visual now complete and formatted, we're ready to proceed to the next step. We want to label each sale as either weekday or weekend based on the date. This helps us analyze whether most sales happen during the week or over the weekend. Weekday sales date 2 returns a number from 1 Monday to 7 Sunday. The if statement checks. If the day number is 6 Saturday or 7 Sunday, it should label as weekend. Otherwise, it should label as weekday. Let's write the formula. Now that the day type column has been created, let's add it to the donut chart. On Home, click the donut chart under the visualization. Add day type under Legend. Then add total sales to values. Our donut chart now shows sales split between weekend and weekday, and we can see that weekday has the most sales. Let's format the donut chart for better presentation. Now our chart is clean, informative, and visually engaging. Let's move on to the next example. In this example, we want to calculate the total sales value for a specific product category, in this case snacks. To do this, we use a data analysis expression measure that applies a filter within the calculation. This formula works in two parts. First, it calculates the total sales value by multiplying price and quantity for each row. Then, Calculate applies a filter to include only rows where the category is snack. Here's the measure we will create. The snack sales measure is now calculated, and we will add it to the card visual we created earlier. The card clearly displays the total sales value for snacks only, allowing us to quickly monitor this category's performance. Now that this is complete, let's move on to the next example. In this example, we want to calculate how much each product category contributes to the overall sales, expressed as a percentage. Since we already created a total sales measure earlier, we'll now build on that to create a new measure for category-wise percentages. This formula works in two parts. The numerator is simply total sales, which returns the sales value for the current category. The denominator uses calculate with the all sales category function. This removes any filters on the category column, ensuring we get the overall total sales across all categories. We use divide to safely handle division and avoid errors if the total is 0. This is a measure because it responds dynamically to filtering and slicing. Our sales percent by category measure is now ready. We'll add it to a donut chart to visually represent how each product category contributes to total sales. To set it up, we select the donut chart from the Visualizations pane. Then we drag the category field to the Legend area and the sales percent measure to the Values area. This setup allows us to see each category's share as a slice of the donut. Next, we format the chart to make it more readable. To create more space for our visuals, we'll change the page size. Go to Canvas Settings, set page size to custom, then enter width 1600 and height 900. This gives us a wider layout that's cleaner and easier to work with. We will now align everything. All set, let's move on to the next example. In this final example, we want to calculate the total sales for the current week and have it update automatically as time moves forward. This measure compares the week number of each sale date to the current week number based on today's date. If they match, it includes those rows in the calculation. The calculate function then returns the total sales for this filtered set. To do this, we'll create a measure using the following data analysis expressions formula. We can now display this value in a card visual. To finish off our report, we're adding a line chart to show how total sales change over time. On the x-axis, we'll use the day. On the y-axis, we'll use our total sales measure. Now, to make the trend easier to see, we'll add a 14-day moving average. Pushpin a moving average smooths out daily ups and downs and shows the overall trend. In this case, it calculates the average sales for each day based on that day and the previous 13 days. This gives us a clean, easy-to-read line that highlights how sales are performing over time, perfect for spotting patterns or shifts. We will move forward and format the line chart. That's it for today. I hope this helped you understand the difference between calculated columns and measures, and how to use each one effectively in Power BI. As a quick recap, use calculated columns when you want to add a new value to each row, like tagging sales as big sale or extracting the day of the week. On the other hand, use measures when you're calculating totals, averages, or percentages, especially when you want the values to change dynamically based on filters or slices. Measures are also the go-to choice for cards, summaries, and visuals that reflect the current context of your report. Think of it this way: calculated columns expand your data model, while measures bring your visuals to life. Thanks for watching, and if you found this helpful, don't forget to like the video, subscribe to the channel, and leave a comment below. See you in the next one.